Hello students, I am Latika Likha and I have been associated with askIITians as mathematics faculty for the past 3 years. And I'll be taking up the topic of matrices and determinants, and my motive of taking up this topic is that when you sit in your examination hall and you attempt your questions on matrices and determinants, you should be able to attempt almost each and every question. And I split up this topic in various segments, like first of all we'll be discussing what exactly do we mean by matrices, then we'll discuss what is the order of matrix, and then we'll be switching to the various types of matrices. Next, we'll be switching to various special matrices like symmetric and skew symmetric matrix, and then we'll be switching to the operations of matrices like addition, subtraction, and then multiplication of matrices. Once we are done with those topics, we'll then switch to elementary row operations, rank of a matrix, then adjoint, inverse of a matrix. Once we are done with all these important topics, finally we'll be switching to the system of equations. In system of equations, we'll take up various methods like Cramer's rule, matrix method, and I'll also discuss the concept of an augmented matrix. And I hope that you will be able to understand each and every topic, and that is why I split up this topic into various segments. So in the first part, we'll be taking up the definition and the order of a matrix, and then I'll be switching to the various types of matrices. So let's begin. So under matrices and determinants, first of all, we'll be beginning with the topic of matrices. When we talk of matrices, what do we generally mean by a matrix? Matrices in general, first of all, we'll be discussing the formal definition. The formal definition or the mathematical definition says a rectangular arrangement, or you can say an array, a rectangular arrangement of numbers in rows and columns is called a matrix. This arrangement is generally enclosed by either this form of bracket or this form of bracket. We call it the small or the big brackets. A matrix is generally denoted by capital letters while its elements are denoted by small letters. So, what do we mean by a matrix? It is basically a rectangular arrangement of numbers in rows and columns, and this is how we denote a matrix by capital letter A equal to either this bracket or you can use this form of bracket, and the elements are denoted by small letters. See A11, A12, A1n, A21, A22, A2n, and so on, AM1, AM2, AMN. See, these subscripts denote the row and the column, and that will be discussed in the concept of order of a matrix, right? So here you just need to remember that the matrix is denoted by capital letters while its elements are denoted by small letters. So next we have is the concept of order of a matrix. This is the most general form of matrix. We have discussed it right now. A11, A12, A1n, so on, AM1, AM2, AMN. So this is generally denoted in this form. A equal to Aij. You can use either form of bracket, and I am writing m cross n, where this m denotes the number of rows while this n denotes the number of columns. So you just need to remember, when we write Aij m cross n, the first subscript m denotes the number of rows while the second one denotes the number of columns. Here Aij denotes the ith row. As we have discussed, this subscript, whenever we write Aij, the first subscript will always stand for the row. So this denotes ith row and jth column. This is the most general form of matrix, and the one more important concept here is the order. When I am writing Aij m cross n, this m cross n denotes the order of the matrix. And this would mean that this matrix contains mn elements. Just multiply these two subscripts and this denotes the number of elements. Now I have an example for the order of a matrix. We have a matrix A of this form. This is the first row. This is the second row. So whenever you need to compute the order of the matrix, what you need to do is just count the number of rows and write it like this, number of rows by number of columns. So here we have 2 rows and 3 columns. So the order becomes 2 cross 3. In fact, if you need to find out the number of elements in a matrix, then just multiply these two, this gives 6. So there are 6 elements in the matrix A. Okay, next we have is the types of matrices. When we talk of types of matrices, this is basically on two bases. Either it is on the basis of the nature of elements in a matrix, or it is on the basis of the order of a matrix, right? So what are the main types? First of all, we have zero or null matrix, then we have square matrix, scalar matrix, lower or upper triangular, which can together be termed as triangular matrices. This is an important concept, this is an important type of matrix. Then we have diagonal matrix, identity matrix, and horizontal or vertical matrices. Okay, first of all we have is zero or null matrix. Zero or null matrix, as the name suggests, is a matrix whose all the entries are zeros. So a matrix of this form, A equal to all zeros, is a zero matrix. Next we have is equal matrices. Again, as the name suggests, two matrices A equal to Aij and B equal to Bij are said to be equal if and only if, this is a two-way condition, each element of A is equal to corresponding element of B. This is an important term, you cannot miss out this term, corresponding element of B, that is Aij is equal to Bij for every I and j, where I varies from 1 to m and j varies from 1 to n. So this is a two-way condition. The mathematical definition says if A equal to B, then that would imply Aij is Bij for every I and j, and if Aij is Bij for every I and j, then we would have A equal to B. Okay, next we have is square matrices, and this is an extremely important kind of matrix, which will be used in the definitions of various other matrices as well. Okay, so square matrix is basically the one in which m is equal to n. That means the number of rows is equal to the number of columns. Then such a matrix is termed as a square matrix. So I have the matrix A11, A12, A1n, A21, A22, A2n, AN1, AN2, ANn. Just note that we have ANN and not AMN. So we term it as an n square matrix or a square matrix of order n. The elements A11, A22, ANn are termed as the diagonal elements. Just see, these are the diagonal elements, or you can say the elements for which I equal to j. These are the diagonal elements. Another important concept that we have here is the trace of a matrix. This is an important concept. You must remember it because it is also generally used in various questions. So trace is basically summation of AII, or you can say the sum of all the diagonal entries is termed as the trace of a matrix. Next we have is a scalar matrix. A matrix whose diagonal elements are all equal and all other entries are 0 is a scalar matrix. So mathematically we can say a matrix for which Aij is 0 for every I not equal to j and m for every I equal to j, where m is non-zero. It simply means that all the 9 non-diagonal elements should be zeros, while the diagonal elements can be any scalar k, but that scalar k must be non-zero. And all the diagonal entries need to be same, only then you will be terming that matrix as a scalar matrix. Next we have is triangular matrix, and this I told you is an important type of matrix, but this is a bit confusing, so just be a bit cautious. A square matrix again, square matrix as we have discussed, number of rows is equal to number of columns. A square matrix in which all the elements below the principal diagonal are 0 is called upper triangular matrix, and a square matrix in which all the elements above the principal diagonal are 0 is called lower triangular matrix, right? So if we have a matrix in which all the elements below the diagonal, principal diagonal, okay, let me take an example. We have an example, all the elements below the principal diagonal are 0. This is a matrix, this is the principal diagonal, all the elements are zeros. So this is termed as upper triangular matrix. And similarly for lower triangular, we have all the elements above the principal diagonal are 0. This is termed as lower triangular matrix. Mathematically, we can say for upper triangular, Aij is 0 whenever I is greater than j, while for lower triangular, Aij is 0 whenever I is less than j. Another important concept that we have here is a strictly triangular matrix. So a triangular matrix is said to be strictly triangular if Aii is equal to 0 for every I, which means that all the diagonal entries are also zeros. So in this case, if I have the diagonal entries as zeros instead of 1, 3 and minus 4, then this would become strictly lower triangular, right? So just remember for upper triangular and lower triangular, because it's a bit confusing concept. So just remember here, in case of upper triangular, the elements below the principal diagonal are zeros, and vice versa in case of lower triangular. Next I have is diagonal matrix. Again a square matrix of any order with 0 elements everywhere except on the main diagonal, right? So mathematically we can say Aij is 0 whenever I is not equal to j. So just remember that the non-diagonal elements are zeros, while the diagonal elements can be anything. They need not be same, they can be anything in case of diagonal matrix. So okay, another important concept here is that suppose we have a diagonal matrix of this form, then here we can write it as DIAG, that means diagonal, and you can write the diagonal elements separated by commas. So I write here 3, 5, minus 1. This denotes my diagonal matrix, this. So this just automatically denotes this kind of matrix. You can write the diagonal matrix in this form as well. Next we have is identity matrix. A diagonal matrix of order n, which has unity for all its elements, is called a identity or a unit matrix of order n, obviously, right? So mathematically we can say a square matrix again is a unitary matrix if Aij is 1 whenever I is equal to j and 0 whenever I is not equal to j. So again non-diagonal elements have to be zeros, while the diagonal elements have to be 1, specifically 1. Then the matrix is termed as identity matrix. So just remember, you should not get confused between identity, diagonal and scalar matrices, right? Because these are a bit confusing because they are a bit same, right? So identity, just remember, as the name suggests, the diagonal elements have to be 1, rest non-diagonal elements have to be zeros. In all the 3 cases, the non-diagonal elements have to be zeros, okay? In case of diagonal matrix, you can have anything in the diagonal elements, 1, 2, 3 suppose, and the non-diagonal elements again have to be zeros. What about scalar matrix? The diagonal elements have to be same, any scalar k, and the non-diagonal elements again have to be zeros. So it must be clear by now, I suppose. Now we have some other kinds of matrices. First of all, we have a horizontal matrix. Horizontal, if you remember, the direction is sideways, this way. Lying position is horizontal. So a matrix of order m cross n is called a horizontal matrix if n is greater than m. Suppose I have a matrix of this form. So this is, we have one row. So we have the order as 1 cross 3 columns. Now here see, n is greater than m. this is M, this is N. Now N is greater than M, so this becomes a horizontal matrix. Again, a vertical matrix is, vertical is this position, upwards or downwards. So this is if M is greater than N, a matrix of this form, suppose 1, 2, 3, 4, 5, 6. We have 3 rows and 2 columns. So here we must have M greater than N. Only then can we say it is a vertical matrix. Row matrix, a matrix with single row. Suppose this is a row matrix. Just one row, any number of columns is a row matrix. Similarly, column matrix is the matrix with a single column. This becomes a column matrix. Just one column and any number of rows is a column matrix. So, okay. Now we have a question based on these concepts. A matrix A equal to Aij M cross N is, now we have to say whether it is a horizontal or vertical matrix and on what basis, right? Now just note one thing here, that you should not mug up the definitions. Just try to understand the concept lying behind the definitions. Otherwise it will be a bit confusing for you. You cannot mug up the definitions, right? So a matrix A, and basically no one is going to ask you the formal definition, but they will be used in various other concepts. So until and unless you understand the concept, you won't be able to attempt the questions. So this question basically says horizontal and vertical matrix, right? Suppose I don't know the definition of horizontal or vertical matrix. So I just take any random example, say 1, 2, 3, 0, 4, 5. I just know that this should be a horizontal matrix because it is somewhat sideways, right? So here I have 2 rows and 3 columns. This much I know. Now what else I know is this is M and this is N. So I try to find out the relation for horizontal matrix. In case of horizontal, this is horizontal, I am getting N should be greater than M, right? So this option says horizontal matrix if N is greater than M. So this is correct. Now just remember, you must ponder on each and every option as well if it is multiple correct question. So now I see a vertical matrix. Okay, now I try to construct a vertical matrix. This is vertical because it is upside downwards, upwards or downwards, right? In this position, standing position. So here I have is 3 rows and 2 columns. So what do I get here? That M is greater than N. So vertical matrix, this option says vertical matrix if M is greater than N. So see, both these options are correct, right? So just remember, just try to understand the concepts lying behind the definitions and you'll be able to attempt the questions very easily. Second question I have is, if matrix A is this, then the trace of A is equal to, now trace again is an important concept as I discussed. Trace is equal to summation I. Summation varies over I, which means the summation of diagonal elements. Sum of all these elements will be the trace of the matrix. So what is the trace? 16 minus 3 plus 2, which means 15. So this is the correct option. So do practice a good number of questions on the types of matrices, as these types of matrices are extremely important because these concepts will be used in various types of questions. So I hope you must have understood by now the definition of a matrix, the order of a matrix. Here I would like to notify that order of a matrix is extremely important and it is the basis for various other concepts. So do focus on this topic especially. And you must have understood the types of matrices as well, especially square matrix, diagonal matrix and triangular matrix. And now we'll be switching to the next topic, that is addition and subtraction of matrices. So do stay tuned.